Hello guys, this is Garv here, and today we are here with the second part on the topic of geometry from the 2003 to 2007 past year PSLE papers mathematics questions. Yes, if you have any doubts regarding the questions in this video or even in any other videos that you would have watched previously, please feel free to put them down in the comment section and I will do my best to answer them. And if those doubts are from like any other video, please do specify which video they are from so I can answer you to the best of my capability. So without further ado, let's get started with the first question. In the figure below, ABCD is a square, AAD is an equilateral triangle, and BFD is a straight line. Find angle AFB. Okay, it is given that AED is an equilateral triangle. This triangle over here is equilateral, and BFD is a straight line. We need to find this particular angle over here, angle AFB. Okay, this is pretty simple. It's not as difficult as it looks like. The first thing we would do is mark the internal angles of the equilateral triangle AED. So angle DAE would be equal to angle AED would be equal to angle EDA, which is 60 degrees. Right? Okay, and we are given that this whole figure is inside a square, meaning that ABCD is a square, right? So this means that angle DAB, this particular angle over here, is 90 degrees, is equals to 90 degrees, and angle FAB can be found by subtracting by doing the following equation. We have angle DAB, which is 90 degrees, minus angle DAF. So this equation over here will enable us to find angle FAB, this angle over here. Now you will get to know in a while why we need to find this angle. So angle FAB would be equal to 90 degrees for DAB minus 60 degrees for angle DAF, which is 30 degrees. So angle FAB is 30 degrees. And now angle DBA. If you see, you have a square, or you have, let's say, two lines over here which meet at this point to form a 90 degree angle, and then you have this third line which intersects through the point which intersects through this point it intersects through this point such that it divides this 90 degrees, or this angle into two equal halves. And if this this large angle is 90 degrees, then the two smaller angles would be 90 divided by 2, which gives us 45 degrees each. And this is the same case for the square as well. You have angle ABC, this angle over here, which is divided into two equal halves by this straight line DFB, which passes through both the vertices of this square, which means that angle DBA, this angle, would be 45 degrees, right? Angle DBA would be 90 degrees divided by 2, which gives us 45 degrees. And we need to find what angle AFB is. Now if you see, we have a fully fledged triangle AFB, correct? Now it's a piece of cake to find angle AFB. Angle AFB would simply be 180 degrees minus 30 degrees minus 45 degrees, which gives us 180 minus 75, which is 105 degrees. So this angle AFB is 105 degrees. Now this is the part for cross checking. Now, although cross checking is not compulsory for PSLE, but it's still a good habit to make sure that whatever answer you get, you can confirm that you can confirm whether it's wrong or correct. So, and usually for cross checking, what we do is you use the final value and substitute it back into the question, but in this case we can't do that. So I'm going to use another method to find if our angle AFB is the right answer or wrong, if the angle we got for angle AFB is correct or wrong. So let me just clear this diagram. Now we know that angle EDA, this angle is 60 degrees, right, since it's an angle inside an equilateral triangle. So we know that angle EDA is equal to 60 degrees, and we also know that angle BDA, this angle over here, is 45 degrees, primarily for the reason I just explained before over here, that you have a 90 degrees angle and it's bisected or divided into two equal halves by this straight line. So over here you have angle ADC, which is a 90 degree angle, and then you have this line DFB, which intersects this angle and divides it into two equal halves. So you have angle ADB, this angle, as 90 degrees divided by 2. So angle ADB would be 90 degrees divided by 2, which gives us 45 degrees. This is 90, right? And now we can easily find what angle FDE is, this angle over here. If I clear this, and now you see, you would observe that this big angle over here, this angle is 60 degrees, and this smaller angle inside it is 45 degrees, which means that this angle, angle FDE, would be 60 degrees minus 45 degrees, which is 15 degrees. And now we know that angle AED, this angle over here, is 60 degrees. This is because it's inside an equilateral triangle, so that's pretty obvious. Angle AED would be equal to 60 degrees, right? And now we need to find what angle DFE is. Now let me tell you one thing, why we are finding angle DFE. It's because we have two lines, angle BFD, angle BFD, we have B and D, and we have line AE, which intersects at point F. This point is F. Correct? We know that AE is a straight line since it's a edge on a on an equilateral triangle. So AE has to be straight, and it is given that BFD is also a straight line, which means that angle BFE would be equal to angle AFB since they are vertically opposite. So whatever angle DFE is, that same angle would be for angle AFB. So we know that angle AED is 60 degrees, and again we form a triangle over here, triangle DFE. So all we have to do now is to find angle DFE. We need to find this angle over here. So angle DFE is simply just 180 degrees minus 60 degrees for angle FED, this angle, and then minus 15 degrees for angle FDE, which gives us 180 minus 75, again 105 degrees. So it means this angle DFE is 105 degrees. And I just explained that angle DFE is vertically opposite to angle AFB. So if angle DFE is 105 degrees, it follows that angle AFB would also be 105 degrees. And this is the same answer as what we got when we used the first method to solve it. So which means you can conclude that angle AFB is equals to 105 degrees. Now I won't say that you have to cross check every single question, but it's a good habit so that you can identify if you've made any mistake or not. In the figure, ABCD is a rhombus and BEC is an equilateral triangle. Find angle AEB. We need to find this particular small angle over here, angle AAB. So in this question, we are not given much. We are just given with the angle BCD and some few pieces of vital information. That triangle BEC, this triangle over here, is isosceles. Is equilateral. And the thing about an equilateral triangle is that all sides are equal in length, which means that BE would be equals to EC would be equal to CB in length, and the internal angles, or all the angles in an equilateral triangle, are equal to 60 degrees, which means EBC is equals to 60 degrees, angle ECB is 60 degrees, and so is angle BEC, which is also 60 degrees. Okay, now we are given rhombus ABCD, right? Okay, so there are a few properties of a rhombus that we must know. The first one, if I draw one out, is that, okay, this doesn't exactly look like a rhombus, so yeah, okay, just assume this is a perfect rhombus, although it's not. So we have A, B, C and D, right? In a okay, you can assume a rhombus, you can imagine a rhombus to be in a square which is tilted at an angle. Normally in a square you would have all angles to be 90 degrees, but in a rhombus you wouldn't have the angles at 90 degrees. So what I mean is that angle BCD, this angle over here, would be less than 90 degrees. Let's say 60 degrees. Okay, so now here comes the important part. In a rhombus, as I said, you can imagine it to be a square at an angle. All the sides in a rhombus are equal in length, which means that DC would be equal to CB, would be equal to BA, would be equal to AD, and opposite sides are parallel, which means that side AD would be parallel to BC, and AB would be parallel to DC. Okay, so you would know that for any two parallel lines, the sum of angles between those two parallel lines would be equal to 180 degrees, right? Which means that if angle DCB is 60 degrees, then you would have angle CBA to be 180 minus 60 degrees. 180 degrees minus 60 degrees, which is 120 degrees. And you have opposite angles, vertically opposite angles. Not vertically, but you would have opposite angles which have the same, which are equal, which means to say that angle BCD would be the same as angle DAB, which would also be 60 degrees, and angle ABC would be equal to angle ADC, which would also be 120 degrees. Okay, so now we have that cleared. Let's head on to solving this question. In the rhombus ABCD, it is given that angle BCD is 18 degrees, and since it's a rhombus, we know that DC is parallel to AB, correct? So this means that angle ABC, this particular angle over here, would be 180 degrees. So we have angle ABC would be 180 degrees minus 18 degrees, which gives us 162 degrees. So this is 162 degrees, and now we have to find angle ABE. We don't know what angle ABE is right now, but we know that angles at a point, the total sum of those angles would be 360 degrees, which means that angle ABE plus angle ABC plus angle CBE would be 360 degrees, and angle ABE is the unknown. So you have angle ABE plus angle ABC, which is 162 degrees, plus angle CBE, which is 60 degrees, is equals to 360 degrees. This means to say that angle ABE would be 360 degrees minus 162 plus 60 is 222 degrees, which gives us 138 degrees. So angle ABE is 138 degrees. Now there's another important thing we must note. ABCD is a rhombus, which means that AB would be equals to BC, right? And okay, let me erase all these unnecessary markings. Right. This is 60 degrees. Yeah. So AB is equals to BC since it's a rhombus, and triangle EBC is an equilateral triangle, which means that BE would have the same length as BC, and CE would also have the same length. So if you see, if AB is equals to BC and BC is equals to BE, we can say that AB is equals to BE. And for triangle ABE, if sides AB is equal to side BE, then triangle ABE would be isosceles, right? And for any isosceles triangle, you know that two sides would be equal in length, and the base angles would also be the same, which means that angle BAE over here would be equal to angle BEA over here. So let's label them as X, since we need to find angle AEB over here, right? And we know that for any triangle, the total sum of internal angles would be 180 degrees, which means we have angle BAE plus angle AEB plus angle EBA, which gives us 180 degrees. And angle BAE is X, angle AEB is X, angle EBA is 138 degrees, which gives us 180 degrees. So we have 2x plus 138 degrees is equals to 180 degrees. So we have 2x is equals to 180 degrees minus 138 degrees, which would give us 42 degrees, which means x would be 42 degrees divided by 2, which gives us 21 degrees. So this particular angle EAB this angle would be, what do we say, yeah, 21 degrees, and angle BE angle BEA, this angle over here, would also be 21 degrees. We need to find what angle AEB is, and angle AEB is this angle over here. Oops. Angle AEB is this angle over here, which we found out to be 21 degrees. So our answer is 21 degrees. Now, frankly speaking, at first I was unable to visualize this particular figure. It kept on coming to me as a 3D figure, but yeah, after looking at it for a while, I was able to solve it. So there would be some questions in the PSLE examination which at first sight wouldn't be so easy, but as you continue to look at the question and try and write down whatever is given in the question, you should be able to solve it fairly simply. So yeah, that's that for this question. So those were the two questions for this video. I know this video was pretty lengthy, like as in lengthy than the other videos that I usually post. So if it was difficult for you to catch any concept or any point, you can rewind the video and watch it again. And if you still don't understand that concept or that particular point, you can put it down in the comment section below, and I will do my best to answer it. And please do like the video and subscribe to my channel and press the bell icon if you would want to be notified every time I post a new video. And since my main aim is to help as many people as possible, whether they're taking the PSLE or not, please do help me by sharing these videos to as many people as you know, so that many people can benefit from it. So thank you.